4.5b, and we're going to graph cosine functions. So if we look at our little circle, and then we got our x and our y axes perfectly drawn. I think my calibration is still off a little bit. We got our initial side, and then we just, make some angle for the fun of it, some little poops and giggles. And we got our little angle theta. Same thing we did yesterday. That little point has an x and y coordinate. And if we're talking about trig, that would be our cosine and our sine. Right? And yesterday we went through and we graphed sine functions. So today we're going to do the cosine functions. So along the same lines. The only difference is now, like when it comes to when it came to sine and our y values went on the y-axis. Really easy to remember, right? But now we're graphing cosine. And where's our cosine going to go? It's going to go in that same place that our sine was, right? But we know like cosine stands for x and stuff. So sometimes when it comes to our x-axis, we know that that is like our angle measurement. So if you wanted to, you could even put like a theta on there. So that way you knew that that was your theta, not like your x values, not your cosine values. And our cosine values are what's going on our y-axis. Yeah. So now we're talking about our x values. So, oops, let me write it up here. Let's do like this, like simple. Well, I guess it doesn't matter. Let's say it's a unit circle. So in a unit circle, what's my radius going to be? Radius equals 1. Right? So when I start to graph this little guy, I'm looking at that very first point when like my degree is 0 degrees, and I need to find my x or my y values if I'm doing cosine. X values for cosine? Right. So what's my x value right there? Anyone? 1, right? Because it's what our radius is, right? So our radius was 1. So if we're at 0 degrees and we're talking about x, well, how far did we go over to get to the circle? We went 1, right? Because we know that our coordinates are going to, our xy coordinate plane, that's always going to be at the center, right? So we know that we're going to start up here somewhere, right? Which is going to be our radius. So now let's think of our x values when we go from quadrant to quadrant. So within that first quadrant, I'm going to go positive, right? So I'm going to go from here to here. What happened to my x values?
Yeah, it went up. Oh.
It went down, didn't it, right? My x values came this way until I got to, what's my x value right there? 0, right? So we know that we got to come down and get to 0. Okay. And then in my second quadrant, we're looking at what values? X. So what happens to x from here to here?
Did you call the negative?
Yeah, it goes to the negative, right? So it keeps going down. Evenly spaced, right? Maybe not quite. Yeah. What about in this next quadrant, from here to here? What are my x values doing?
0.
Yeah, they're coming back up to 0. Mhm. And then from here to here, what are my x values doing? Climbing? Yep, climbing back up to whatever our radius was, right? Or 1. So I'm going to go like right about there. So, of course, I stink at plotting things. So, remember how that sine wave, remember how it was a wave? So the same thing happens with cosine. So this isn't like no like big old parabola, because technically what would happen if I went to the left? It would go down, right? Same thing over here, what's it going to do? It's going to go down. So you kind of try to put a little curvy to it. And you got to come down. Whoops, that was a really bad come down. I failed art class. We got arrows on our ends because these babies are going to keep going forever and ever. Looks like a reindeer. Maybe. So yesterday when it came to our amplitude and our period, like all of those apply when it comes to cosine as well. In math, there's always trying to find those patterns, right, that kind of keep repeating. So when it comes to graphing trig functions, like that same thing kind of keeps happening through all the different functions. Granted, this looks a little bit different than sine, but everything that we did in order to graph it, all of those little steps, it's all the same steps, right? So what do you notice the difference between when we graphed a sine wave and a cosine wave? Anybody see like the biggest difference?
That one looks bigger.
Oh, might have been the way
Oh, it started at 0 for the other one.
Oh, yeah.
Hi, Jesse.
Yeah, smarty.
I'm sorry.
Jesse's the smarty pants. No, exactly. That's exactly what we want to look for, right? Anytime we have a sine function, our sine function is going through the origin, right? Or going through where x and y are both 0, right? And then when it comes to the cosine that we just did, does it go through the origin? No, it's going to go through whatever the radius is, right, to start with. Nice. If it was negative, where do you think it would start? Yeah, it would be down if it's negative spot. Yep. So when it comes to, and you guys got to get this at the very end of our little lesson, I get to make a little graph for you guys, and then you got to tell me if it's cosine or sine, right? So you should be able to look at it, and wherever it's crossing the y-axis is going to tell you if it's sine or cosine. All right, you want to graph one of these just for the fun of it?
Sure.
All right. How comfortable are you guys graphing the signs? Okay on it? So I could give you a crazy one. It's going to make you go, what? Or you want the easy one?
What's like, is like the hard one a fraction?
Fractions are your friends. They're all fractions. All right, we'll do 2 then. Okay. So let's say they gave us y equals 2 cosine of 1/2 x. So first thing we always like to find is the amplitude. Right? Amplitude is the absolute value of A. So what's that going to equal for us? 2. Yep. And then B was finding the period. So to find the period, we do 2 pi over b, right? So what are we gonna have? 2 pi over 1/2. So that means we gotta multiply by the reciprocal. And what are we gonna get? 4 pi, right? Makes me hungry doing trig functions. And then for C, we had to find those important points, right? So we had to find when x equals 0, so it's gonna be our y-intercept, right? What's our y-intercept gonna be? When x is 0, where are we gonna plot that point?
2.
2, the positive 2, right? Yep. So we know that's gonna be at 2, right? And then we had to take our period, divide it by 4 to get our other points. So, oops. So 4 pi divided by 4 is going to give us pi. Right? What's our second point going to be then? Or technically our third point, but 2 pi. Yeah. Yeah. What's our next one going to be? 3 pi. And our last one's going to be 4 pi, right? And that 4 pi better match our period, right? To where we know we counted them right. So now we can draw our little xy axes, little coordinate plane. Yeah. Oh, whoops. So now we're going to end at 4 pi. Half of 4 pi is 2 pi. Half of 2 pi is pi. And 3 pi. Okay? We got 1, 2, -1, -2. Yeah. So our first point, when x equals 0, we know we're going to go to a positive 2, right? Because ours was positive. So that was our first point. And then what are we going to do? What's going to happen at pi? Yep, it's going to be at 0. What happens at 2 pi? -2. Yep. What happens at 3? At 0. And at 4 pi? Yep, 2. We're all the way back around the circle, right? And the more you practice these, the better you get. And it keeps going forever, like all of our little functions. So we're going to throw some arrows over there. Right? And then we know that from 0 all the way to 4 pi, that is 1 cycle. Right? It would take me all the way to 8 pi to go around it twice. Does that make sense? Getting easier a little bit the more and more you practice, just like everything, right? The more and more you practice, the better you get. All right. Let's try another. Feel like I'm on a roll. No?
Whenever you get the absolute value of a fraction, does it stay a fraction?
Mm-hmm. Yeah, because it's still the distance, right? So you can have a half a foot distance or something, yeah. All right. So let's say we have y equals -3 cosine of pi over 2x. Throw a little pi in there. Why not? There. So the first is our amplitude. What's our amplitude going to equal?
3.
3. Good job, good job. The second one is our period. So that's what, 2 pi over b? So 2 pi over b. What's our b? Pi over 2, right? It's that whole thing in front of that x. So pi over 2. So what are we going to do? Multiply by the reciprocal? Do I need to write it out? Or can you get 4 pi over pi. Yep, and what's going to happen? Yep. So our period is 4. Isn't that nice? Yeah. So our little important points. So the first one is when x equals 0, right, our y-intercept. Where are we going to cross the y-axis at?
-3.
-3, good job. Yep. That's going to be -3. Then we got to find our other little point, which is our period divided by 4. So what's our first point going to be? 1. And then 2, 3, and 4. Started off a little complicated, but then it got a little easier, didn't it? Right? Got a little coordinate plane going on. We gotta go to 4. Our amplitude is 3, so our distance is 3 up and 3 down. It's always great in baseball. So where do we want to plot our first point? And we're going to cross the y-axis at -3, right? And then what are we going to do? Yep, go up to 1, yeah. And then what's going to happen to our x values? Yep, go up to 3. And that's going to do what? Drop to 3. Or drop to 0. Whoops, sorry. Yep, and then drop to -3, right? Sometimes in life, just make your dots bigger. Or your points stronger. Make little mountains and out of molehills. How you guys feel about those? Easy peasy lemon squeezy? Okay, alright. So I'm going to give you guys like 60 problems of these.
Whoa.
No. Alright. Maybe you guys want a quiz on these, huh? Alright. So you guys gotta bear with me, I gotta draw you guys little pictures. We're gonna see if we can write the equation from a graph. Whoa! We're just like, we're throwing it all out there. So write the equation, oops, from the graph. Alright, I gotta have myself some little reminders. Don't look yet. Alright, ready? Hard part of this board is my hands like cover, my shadows get me, and I can't see through the shadows. Alright. Perfectly drawn graph, right?
Yep.
Yep. So, with all of our technology that we have, we've lost our sense of imagination. So it's my goal to bring some imagination back into your guys' life. How's that sound? Now my fancy art students in here are just like shaking their head at me right now. But perfectly drawn. So when we look at graphs, we want to ask ourselves a few questions. We want to ask ourselves, is this a sine or a cosine graph? Anybody got any thoughts on which one this one might be?
Cosine.
Cosine. Cosine?
Oh, cosine.
Cosine, right? Why are we going to pick cosine?
Because it goes through not the origin.
Yeah, it goes through not the origin, that's, yeah, right, exactly. It's gonna go through that radius or amplitude, right? The next question you guys wanna ask yourself, since we know that it's cosine, we need to know if it's a positive or a negative cosine.
Positive.
Yeah, it's a positive cosine. Then we want to be able to figure out what our amplitude is. So our amplitude is like the distance from 0, right? So what is it?
3.
3. Yeah, so we know that our amplitude is 3. I don't know if I need to circle that one. Yep. And so then the other thing we need to figure out is what our period is. So our period is that 2 pi over b, right? So we want to figure out how far does it take in order for this, for one cycle, right, for it to actually repeat. So I'm going to start, oh, you guys probably can't see me now. I'm going to start here, right? And I want to know how far does it take in order for me to get back to that spot. So I'm up, oh, nope, not there yet, I'm not there yet. Oh, I'm starting to get closer, I'm starting to get closer. And what happens right there? Like I'm starting all over again, right? And that's my one cycle. So how far did it take me to get there? 4 pi, right? So my period, oh. This guy is going to equal 4 pi. Okay. We need to figure out what our b is. So if you guys need to, write it as a fraction if it's not a fraction. If two fractions are equal, they are proportionate. Okay. How do we solve ratios or proportions? Come on, guys. Cross multiply, right? So 4 pi times b equals 2 pi. What are we going to do next?
Get b by itself.
Yep, how are we going to get b by itself?
Divide 4 pi over.
Yeah, divide by 4 pi, right? Yep, good job. Divide by 4 pi, right? 4 pi over 4 pi is 1.
Pi over 2.
Well, what happens to our pi's?
Oh, it can't.
They can't,
So
so
it should be 2. Right?
So
No, 1 over
1
2.
half.
do half, right? So I think we might have everything in order to write our equation out. So y equals, what was it, a cosine of dx. Right? Do we know our a?
Yeah.
Do we know our b?
Yeah.
Yep, we knew that it was cosine, right? And then we know that it's positive, so y equals, we know it's positive, so we don't have to put the little positive symbol. What's our a?
3.
3. We know we're doing a cosine function of b, which is 1/2. And then our x,
Oh, yeah.
right? So you guys just did the exact opposite, right?